Hey, Year 12s, welcome to exercise 9.1. We're going to take a look at using matrices in real life, and hopefully chapter 8 went well and the S&M task you've completed, or the quiz. If you haven't, please get that through to me as soon as possible. Once again, this chapter is mostly what the exam and SAC is based on. They're never going to give you a matrix in the exam, at least, based on the chapter 8 questions, but they will always put a context to the matrices questions in the exam. All right, so it's really important that we're able to read and then convert what we read into matrices, and also making sure we've included the right amount of information. So, example 1, each week the coach of the Little Diggers basketball team awards the best and fairest player award to the player who scores the most game points. Now, is that fair? Probably not, because, well, there's a lot of other things that go on in sport. But let's just say the person who scores the highest gets the best and fairest. In the table below, we've got 1, 2, 3, 4, 5, 6, 7 players. So Asma all the way down to Sophie. And we've got a tally of the number of 3-pointers, 2-pointers, and 1-pointer each player has scored. For example, here we can see Sarah has scored 1 3-pointer, 3 2-pointers, and 2 1-pointers. So her total points would be 3 plus 6, which gets us 9. 9 plus 2 gets us 11. So she would have scored 11 points in the game. Question A, write a column matrix. So it's really important we highlight what sort of matrix they want. So write a column matrix P to represent the 3 different scores possible. All we have to do is we go, well, in basketball, you can get a 3-pointer, a 2-pointer, or a free throw that's worth 1 point in. And what we've done is we've just wrote 3, 2, and 1 as a column matrix. Okay, nothing too spectacular there. Here, what we have to do now is write a matrix G, okay, to represent the data from the table. So whenever they tell us to write a matrix G, let's just make sure we're always labeling it. Okay, you'll see later on when they stack the questions on top of each other, and it's that reason why you know which matrix is what letter. All we've done is we've converted 0, 5, 0 and this entire table into a matrix. So we've gotten rid of the names, we've gotten rid of the number of points, and we've converted it into one simple matrix so we can put in our CAS. Remember, this is all CAS based. You don't need to do anything by hand unless you really want to. Question C, use matrix multiplication to find a score matrix named X. So matrix named S. Let's use a different color actually. It's deleted the S. Okay. So matrix named S. All right, and what it is, it's the G matrix from above times the P matrix from above. So let's use different colors. Let's change that to green. Column matrix P. All right, so then we can get some color coordination. So it's the G matrix from part B. This is going spectacular. And the P matrix from part A. You multiply the 2 matrices together, so these 2. Remember, the order is G times P, so this matrix here times this matrix here. In your CAS, once you've done that, it should spit out 10, 11, 14, 16, 17, so on and so forth. While we're here, let's highlight the matrix as well, so we won't ever forget. Again, highlighting is really important. I can't emphasize enough how important it is to underline or highlight the questions in matrices, okay? Because once you get it, there's really no way people get it wrong other than misreading the question, which happens quite frequently. Okay, so a lot of people write a row matrix instead of a column matrix. And they'll go, well, why doesn't it work in the CAS? And vice versa. So really important we underline and highlight. Right, now that's done. Part D, which player won the best and fairest award? So what we have to do here in D is we take a look at what we got in part C of the question. And remember, this says use matrix multiplication to find a score matrix named S that represents the total scored by each of the players. So we look at the highest number, 19's the highest, and we go back to the original table and we go, who's the last person? Last person is Sophie, so she must have scored 19 points. And that means she's going to win the best and fairest. Okay, so we'll go and highlight this. So the 19 points is from up above. And we can see Sophie is going to get the award. All right. Hopefully that's making sense a little better. Part E, the opposition scored a total of 87 points. Did the Little Diggers win the game? Well, what we figured out in Part C was the total of what everyone scored. So if the 7 players scored 10, 11, 14, 16, 17, 6, and 19 respectively, what we can do is we can actually add all those numbers from above. Okay, and remember Sophie was the winner, so she had 19. All right, if we add all those together, we get the total points that Little Digger scored, which is 93 points. And from there, we can say, well, the Little Diggers won by 6 points because 93 is higher than 87. That's all for example 1. We've got 3 examples to get through. So I'm hoping the highlighting makes it a little bit clearer where we got the numbers from. Remember, it's really important you label the letters that they want and get in the row and column matrices right. Example 2. So this is probably a lot more practical and what matrices are actually used for in a business. The manager of a local hardware store purchases small metal fasteners for $3 and large metal fasteners for $5. In the last 2 weeks, he purchased a number of fasteners showed. Part A, find the 2 matrices that can be multiplied to give the total purchase cost of metal fasteners in each of the 2 weeks and complete the multiplication. So first part of critical information we have is we've got small metal fasteners, $3 each. And then we have large metal fasteners, $5 each. What we have here on the right is week 1 and week 2, how many small metal fasteners, I guess, were purchased, and how many large metal fasteners were purchased by the shop. So the key word here, purchases, is also quite important. So just make sure we're aware of what's going in or what's going out of a shop. So we got to come up with 2 matrices that can be multiplied together. Remember, the order of the matrices is really important. So this here is a 2 by 2. This here is a 2 by 1. Because these are the same, we can actually go with this matrix. Now, how did we get these 2 matrices? What we have is the table here we've converted into the matrix on the left, or the matrix on the left, and then the content from above, the 3 and 5, we've drawn from the written text. Okay, so it takes a little bit of problem solving. It takes a bit of reading too. If you're not focused, these questions can be quite challenging. And if you were to go the other way, so if you had the 3 and the 5 the other way with the green matrix on the right side of the 3 and the 5, you can't multiply those two matrices together because 2 by 1 and 2 by 2, these two values would be different because that would be a 1 and then the value here would be a 2. So the order really matters when we multiply. Once we've come up with the details, you put this into your CAS and you get your total cost. Okay, so this here tells us the total cost. So week 1 total cost. This here is the week 2 total cost. And cost is important for a business because obviously when you're selling a product, you need to know how much you need to sell to break even, so you're not losing money on purchasing the product. Because if you purchase more than you sell, you're usually losing money up to a certain point. Part B of the question says the manager sells goods at 55% markup, and he recorded his purchase costs over the last 2 weeks for metal fasteners and 3 items in the following table. The following table is given here, and what we need to realize is, well, we were talking about metal fasteners up here. What we figured out was week 1, they bought $923 worth of small and metal fasteners, and in week 2, they bought $705 worth of small and large metal fasteners, and we need to fill out this table from above. Okay, so let's just make sure we've got this down somewhere. All right, so these values here gets filled out in the table. That's shown down below. Right, so the 55% markup's really important. We're going to highlight this actually. They sort of assume you know what a markup is. So a markup is when you want to make a total, red's really bad. They want to make a total or a percentage of profit on each sale. For example, if I bought bread for $1 and I mark it up by 55%, that means I'm going to sell that bread to you for $1.55, meaning I make 55% in profit. Green's pretty ordinary as well. What's a good color? Yeah, screw it, we'll just use red. Hopefully, we won't miss that. So 55% markup for 2 weeks of purchases. That's going to be relevant for later on. BI says represent these costs in a 4x2 cost matrix C. So we call this matrix C. And we've just literally converted this table into a table like so. Let's see, let's use this color. Oh, it's not highlighted. Okay, so matrix C, we've got this color, kind of gross, but it'll do. Part 2 of the question says, using scalar multiplication represents selling prices of these two matrices in a 4x2 matrix called matrix X. Matrix X, S, yeah. So the markup is going to be what our selling price is. So remember with that bread example, if I bought bread or made bread for $1 and I wanted to sell it with a 55% markup, that means the bread's going to be sold for $1.55. Now, how do we represent the 55% as a scalar? You put a 1 in front of the 55. Okay, so the 55 or 0.55 came from the 55%. Remember, 55% is 0.55. The 1 includes the cost price, and then that tells us what each item has to be sold for that 55% profit. again, this matrix here that we're multiplying with is the one from above. And again, if you hate this highlighting, you can do your own, or you can just preview it and then it won't show. Once you multiply the two together, you're going to get a new matrix. So if you put this in your CAS, for example, the top left, the paint that costed $1,060 in week 1, for them to make 55% profit has to be sold for $1,643 in total profit for that to happen. Let's give this matrix a new color. We'll give it this weird green. Okay, so that's matrix S. I know, a lot of matrices, right? Part C, create a profit matrix. So again, they're assuming you know what a profit is. Remember, if you have a business or if you've done business management, you've got a significant advantage. The profit is simply the selling price, take away the cost price. What does this mean? Well, matrix S here is going to have to be deducted by matrix C. So if we go back up, matrix C is that weird tan color. And what you do is you put those two matrices in your CAS, or you can do it in your head if you really want that challenge of just doing a simple subtraction 8 times over. You'll get this matrix of 583, 855, so on and so forth. This tells us how much profit was made on paint in the first week in the top left, paint in the second week in the top right. What was the second row? Let's see. Second row was timber. So with timber, they made a lot more money, $1,665.95 in the first week and $618.20 in the second week. This is a metal fasteners profits, so on and so forth. I'm hoping this is making sense so far. Double I, calculate the total profit to be made if all the goods purchased over the 2 weeks are sold. So assuming they sell everything and they've got this outcome here, what we do is we add all the values from this matrix and that's going to tell us the total profit. Okay, so let's give profit a color. What color should profit be? Let's go grey. So this here is our profit matrix. And all these values came from that profit matrix. All right, and the total is $5,787.10. So the business would be thriving in those 2 weeks. Our last example, matrix B shows the number of sightings of rare birds made by members of a bird watching club. So matrix B here, we've got the names of the bird watchers, Harry, Essa, and Aniela, and Gordon. And then we've got the types of birds up top with flitter, bitwing, and redwit. We've got a summing matrix, so called matrix P. If it's a row summing matrix, it's always going to add the columns totals. If we have a column summing matrix like matrix Q, this will always add up the row totals of the standard matrix. Okay, so the first question tells us create a matrix A by multiplying matrix P and matrix B together. So matrix P is our light blue one, which is the summing row matrix. And matrix B is our standard matrix of the results of the people bird watching. Now the order is really important. It's got to be P first and then B second. Otherwise, if you get the order wrong, sometimes you can't multiply the two matrices together. What we get is matrix A, which tells us the total of each bird type seen. So 13 plus 2 plus 1 plus 5 is 21, and that's what these two operations did. Right, so what information does the element A13 give? Well, sorry, not A13, A row 1, column 3. So row 1, column 3. This 19 here tells us how many redwits were seen by the 4 sightseers or bird watchers. So if you add 4, 2, 3, and 10 together, you get that 19 right there. Let's highlight the two matrices. We just figured out. Perfect. So, part B, calculate C, or matrix C, B times Q, and describe the information given by C. This is weird. What's happened? There we go. So, what we have here is matrix B. What color did we do matrix B in? Matrix B was in yellow. I should have wrote a matrix C equals here, but hopefully you will do that in your notes. And matrix Q, what matrix color was that? Green. We multiply these two in that exact order because remember the order matters, so it's not Q times B, it's B times Q. And what we get is matrix C. And we'll give this a new color. Matrix C can be gold. So, what does matrix C tell us? Because the second part of the question says, describe the information given by matrix C. Matrix C tells us the total birds observed by each person. Remember, if you have a column summing matrix, it's going to add all the rows together. If you have a row summing matrix, it's going to add all the columns together, as we saw in example A. Part 2 of question B, what information does the element in matrix C, row 2, column 1 tell us? So row 2, column 1, that is row 2, column 1, this number here. Okay, we have to go back to our table and see who or which person was in the second row. And the person in the second row was Essa. Oh, what a challenging name to say, Essa. Okay, so that's how we got Essa from the table. The very last question, calculate a quarter times matrix P times matrix B times matrix Q and describe the information given by this matrix. So this is actually the same as saying a quarter times matrix P times matrix C because matrix C was the answer of B times Q. So remember we did B times Q already, so we can just take this orange or gold matrix and plug it in here. Instead, I mean, you could do B times Q. There's nothing wrong with doing the yellow times the green again. I'm just trying to save a little bit of time for you. Instead of punching in all these numbers, you can just punch in this one. But there's no issues with doing yellow times green again. It's up to you. The row matrix, what color did it have? That cyan, or light blue. So this was a light blue matrix. That's the gold matrix. And what we get once we've put that into our CAS is the answer of 14. What this means is the average bird sighted by each person is 14 birds on their trip to wherever they went to go see birds. All right, that's all for exercise 9.1. We're going to spend again probably 2 or 3 sessions on this. Remember to really read the questions and send through any emails you have if you don't understand. Lastly, don't forget to do the S&N task of Chapter 8 if you haven't done so already. Thanks to those who've emailed it through. We've had some pretty good results. All right, thanks everyone.